All right, in this video we're going to talk about how to graph the absolute value function. So the absolute value function looks like this, and so if you have f of x, which is also y, it just equals absolute value of x. And so we're going to do a table right here like you used to do in Algebra 1. So we're going to plug -3 into there, and imagine what we get. We'll plug all these numbers in there. So that's our domain. So now's a good time to talk about what can you plug in there. Well, I can take the absolute value of any number. So my domain is from -infinity to infinity. You can do any real number in there. Okay, so let's see also how that looks on the graph. So if you do the absolute value of -3, you get 3. Absolute value of -2, you get 2. Here you get 1. Absolute value of 0 is 0. And then 1, 2, and 3. So basically, absolute value basically turns your item inside positive, right? Or turns 0 into 0. So if you graph these points, -3, 3, -2, 2, -1, 1, 0, 0, graph all the points, and it starts to look like a V shape. So if you kept going further, it would just keep going out and out here. So basically we're going to have a V shape like kind of right in the center of our graph. So here to there. And so this spot right here is important. That's the vertex of our graph. So vertex is, like a corner or like a kind of like a turning place or whatever, but a sharp turn like that. So that's our vertex. And so that's the place where we're going to, when we talk about it moving around, we're going to make sure that we know where that new vertex is. All right, so let's look at the domain. So this graph goes right forever, left forever. That's our domain, remember. So that's why we have all real numbers. But if I'm looking at up and down, it does not go down and up forever. It goes up forever, but only from here up, right? So that's from a level of 0 up. So when we talk about our range, we have 0 to infinity. It's touching 0. Our local max or mins, so that vertex point is going to be a minimum right now. It's actually the absolute minimum because it's absolutely the lowest place on the whole graph, but it's also a local minimum. We don't have a maximum. X-intercepts, so looks like 0, 0 is also an x-intercept and a y-intercept. That's the one place, that's both, okay? Increasing intervals. So remember, increasing interval is a positive slope area. So that would happen on the right side. You see how the slope is up 1 over 1? Okay. Excuse me. And that starts from 0 and it goes all the way to infinity. So this whole section of our graph is increasing, a positive slope. So, and while I'm at it, why don't we talk about decreasing slope? So that would be this side. This side has a negative slope. Down 1 over 1, down 1 over 1. So this side right here is decreasing, and it's the whole left side from -infinity to 0. Okay, and when we do increasing and decreasing, we're going to use parentheses around there because it's not decreasing or increasing at 0, but right before it, it's coming down towards it. All right, and then over here, this starts at 0 and goes to infinity. So remember, we're naming x intervals. We're doing sections of the graph, the x values, because we're talking about like a section here and a section here. Okay, so we're doing the x values. So it's increasing from 0 to infinity and decreasing from -infinity to 0. So we make sure we put these numbers from lowest to highest, and so sometimes it feels a little bit weird, but constant. Constant would be like a flat area, so there is none here. And our end behavior. So our end behavior is going to be what the ends of our graph are doing, right? So as x is going to -infinity, that's this way. So as I look at the left side of the graph, so that's the left side of my graph. So I'm going to go ahead and put infinity here. And then as x is going to positive infinity, that's this direction. So I'm going to look at the right side of my graph. So let's put infinity there too. They're both going up. So this is the easiest case. All right. Oh, that one's a little bit ugly, isn't it? All right, so some basic transformations that you can do. You can move left or right. And so I'm going to do a couple of these graphs and just show you what I mean. So if you had an equation like this, let's say you had the absolute value and you put x minus 3, let's say. So imagine what goes on there. So what you're doing, if you want this part to become 0, then you'd have to put a 3 here. So your new place where you get an answer of 0 is going to be a 3, right? And so if you kind of imagine what's going on there, what's going to happen then is 3 is going to be your new 0. And so that's going to be your new vertex. And so then from there you go up 1 over 1. Okay. So you can see that if you want to move to the right by 3, you're going to have to basically have the expression x minus 3 in there. So let's try another one. Let's say we had y equals absolute value of x plus 2. So imagine what would happen there to get this expression to be 0, like your new 0 spot would be negative 2, right? So negative 2 is going to be the place where your graph starts, and it's going to go up from there. All right, so negative 2 and then, up 1 over 1. Now the slope of these lines can change, but we'll talk about that at the end. All right, so this is going to move you to the left. So whenever you have a x plus something inside there, you're going to be moving to the left. All right, up or down. So if you want to move a graph up or down, what you do is you maintain your absolute value, because we're not going to move right or left. We can do both at once, but we'll do that on the next page. So if I want to move up or down, what I do is I want to add something to the height. So it's like I want to take these numbers and I want to add something to it. If I want to move up, I want to raise the height. So what I would do is take my absolute value, and if I put, like, let's say plus 4. So what that does is it adds 4. So if I was going to be at 0, now it's at 4. If my next point was going to be at 1, now it's at 5. My next point, 2 is now going to be at 6. All right, so it basically raises everything up 4 spaces. All right, so I only have a little bit of space. And then let's say if we had absolute value of x and we put a minus 1, let's say. So everything basically that I had up here is moving down 1 space, down 1 space, down 1 space. Okay, and so if I do that, it puts me here. Okay, so this one's down 1, and this one was up 4. All right, so you can see that if you want to move left or right, you put a number inside, and it's the opposite of what you might think. Like when you want to move to the right, this has to be a subtraction, and when you want to move to the left, it has to be addition, so it's kind of opposite. But when you want to move up or down, it's really what you think. Like when you think up, you're like, oh, plus, and minus is down, okay? So to cause a reflection over the x-axis, what you're going to do is you put a negative sign in front. So what it does is it causes all these numbers here to be their opposite, right? It flips them down. So like this number flips down to -1, -2, -3, and so forth. These flip down. So what you end up having is a V shape, but it's flipped down, upside down. All right, that line is a little bit off. Make some dots here. All right, well, that's not much better, but okay, so next we come to these things called a stretch and a shrink. So also these are called dilations, right? So a dilation, normally you're thinking of something getting bigger, because like when your eyes dilate, but it's also used in the term of something getting smaller, because you're going to tell someone like dilation by a factor of, and then you're going to tell. So let's try this one. So let's try 2 in front of here times x. So what that does is it takes all of your answers here and multiplies them by 2. So this is now going to be 6, 4, 2, 0, 2, 4, 6. So it raises up your y values. Your x values are staying the same, but your y values are getting taller faster, or higher sooner. All right, so this is called a dilation by a factor of 2. All right, so you say dilation by a factor of 2. So if you're dilating by a factor of 2, that means everything's getting bigger. You're stretching is what you also call it. So 0 times 0 is still 0. But when I used to have 1, 1, now it's going to be 1, 2. It used to be 2, 2, but now it'll be 2, 4 because I'm doubling. And then it used to be 3, 3, but now it'll be 3, 6. So everything's raising up. And so with absolute value, it's very easy to tell, because what you end up seeing here is you end up seeing a new slope. See that slope? That slope is 2 over 1. Okay, so that number in front basically tells you your new slope. Okay, and then the next one is a shrink, but it's also called a dilation. So let's say you had a vertical dilation by a factor of 1/3. So really you're saying, hey, I'm getting bigger by 1/3, but so that means you're really getting smaller. So it's called a shrink, but you still call it a dilation. You're just telling someone, hey, it's a dilation by a factor of 1/3. So that means you're multiplying by 1/3, meaning, oh, I'm getting smaller. So what that does is it basically makes everything shorter. Everything is a third of its height. So everything's like bringing down by a third, or like, I'm sorry, it's going to a third of its height. So 0 times 0 is still 0, or 0 times 1/3 is still 0. But think about the point 3. If I multiply 3 by 1/3, I get 1. So this point that used to be here at 3, 3 is now at 3, 1. And 6 was going to be 6, but a third of 6 is 2. So 6 is now going to be 2. And so, like I said earlier, you can think of that number in front as your slope. So it goes up 1/3, up 1, oops, up 1/3, up 1/3. So it creates a slope of 1/3. Okay, all right, so let's put some of these things together, and we're going to basically have a few of these things all at once so you get a little bit better at doing it. All right, so right here, so this makes my new 0 spot at +2. So it's going to move me to the right 2, and remember this pushes everything down 4. So right 2 and down 4 is going to be my vertex, and then I don't have a slope change in front, so it's going to come up. Whoops. Okay. Over here, this is going to be my new center spot is going to be -3. So this means I'm going to move to the left by 3. All right, and this right here, remember that's my dilation by a factor of 2, or we can also call it a stretch. So either way, so dilation by a factor of 2, or we can call it a stretch. So I'm going to move left 3, and my new slope is going to be 2/1. Okay, all right, now be real careful with these absolute value graphs because it's really easy to tell if you graphed it correctly. So like this one, this one, this one, you know, you want to go hit those points like really well, even though I didn't. All right, let's look here. So this is going to move us up 2. And this guy right here is going to be a reflection over the x-axis. So I'm going to move up 2, and I'm going to flip upside down. My slope is still the same, 1/1. Okay. All right, oh, we got a lot going on here. So we have a reflection, we have a dilation by a factor of 1/3, or we can call it a shrink. Now, we'll talk about this in a second, but this is definitely moving me down 1. So this is a little bit strange here. So think about this. What number would you put inside there to make your graph come to 0, to make this expression right here be 0? You'd have to put a +2 right here, correct? So if you put a +2 right there, then it's going to be 0. So +2 is your new, like, it's moving to the right by 2. So this does move me to the right by 2. Now what's also happening, I'll explain in a second, is you could write that expression as 2 minus x. Right? So that's also another way you can see how 2 is the new 0 spot. But when you have the graph like this, when the x is negative, then what you're really doing is you are reversing, you are doing a reflection over the y-axis. All right? So really what this graph is doing is, one thing you can see is that it's moving to the left 2. So it's moving to the left 2, but then it's reflecting over the y-axis, so it's really over here at positive 2. So there's a couple of different ways you can think of it. And with absolute value, if you take a normal absolute value graph and flip it like left and right, and not up and down, but left and right, you don't notice a change, right? So, this graph is kind of special in that way. But if we had a graph that was like this, let's say, if we flipped it left and right, it would turn into this. So we would notice it. But with absolute value, we don't. So either way you want to think of it, we'll still know that we're going to start to the right 2. Okay, so let's see, right 2, down 1. So there's my new vertex. I have to make sure I'm upside down and my slope is 1/3. So there's 1/3, there's 1/3. All right, and so go a little bit further that way. There's my new picture. And of course you can check these on Desmos or your calculator. All right, so now here we're going to tell the equation based on the picture we see. So I'm just going to do y equals, and I notice I moved up 2 spaces. So I want my absolute value to not move left or right. I'm going up 2, and then notice my new slope, up 3/1, 3/1. So I have a dilation by factor of 3, or a stretch by factor of 3. All right, over here, I'll move to the right 4. So I did not move up or down. So I'm going to do x minus 4 to make 4 my new 0. I don't have up or down, so I'm not going to put anything out here. But look at this thing. It's upside down, so I know I'm going to have a negative sign here. And look at my slope. Down 1/2, 1/2. So it's a slope of 1/2. So I have a negative and a 1/2. All right, on this blue one here. So I'm not flipped over. It looks like my slope is like 1/1, so no changes there. But I did move right and down. So I moved to the right 2, so x minus 2, and down 4, so minus 4. All right, here I have all the changes possible. So first of all, the big thing to notice, I have moved to the left 3 and up 5. So I'm going to leave a little bit of space in front. Left 3 and up 5. I'm upside down, so I know it's a negative, and let's check out the slope. Let's see, here's a good place. So it's down 3/2. Down 3/2. All right, so I'm going to put 3/2 here. So I have a dilation by 3/2, and so that's actually a stretch because 3/2 is bigger than 1. All right, so that's how you graph.